Hi everyone, welcome back to my math teaching channel online today. Today I will get right into the derivative rules. Before we get into the derivative, let's recall a little bit. What is the derivative? And in those previous lessons, I have shown you the derivative basically is just the rate of change. And how do we measure the rate of change of two things in the real life? The distance of our car driving and the time taken for us to ride our function driving on the street, right? So the rate of change measured by the slope in linear function you learn in Math 9, Math 10, we call a slope of a linear line, which is delta y over delta x. And it equals y2 minus y1 to find the distance of the rise, divide by x2 minus x1, the distance of the run horizontally. So that becomes the ratio of the slope of the linear. And because when we're talking about linear, we're talking about the constant speed. Your car assume that driving 80 kilometers an hour never change. And keep going and it can keep driving, never change. So we have a constant speed, and that's why we use a linear function to demonstrate, to present it. Now, in our real life, we drive a car, sometimes we go uphill, sometimes we go downhill, and it's become a wavy curve. So our function no longer to be linear, and therefore, when we want to measure the rate of change of our slope, we have to try to pick a particular point and we call it instantaneous velocity. And the instantaneous velocity at that time, at that moment, if we use a derivative, we will be able to find our instantaneous velocity at a specific time. And on the graph, we present it by the y function is the function of your driving over respect to the time taken happened is the x value, right, on the graph. Now, so we say derivative is the slope of a tangent line at a particular point equal delta y divided by delta x, and it equal limit of f of x plus h minus f of x divided by h. Now, I already explained this abstract formula, right? So I don't bother to go through it anymore. I just recall it for you. And remember, if you relate it to linear, this fx of h, x plus h, the same like y2 minus y1 divided by x2 minus x1 for the h value, except that because our speed no longer a constant, right? It's a curve. So therefore, whatever the function of the curve is, we have to plug it in here to find out the y changing at any particular point minus with our y function, and the h down here, we want to make the tangent, the secant line become a tangent line. This h have to go to the distance of x2 minus x1 have to go to 0 so that we can change the secant line become a tangent line, and we come up with this value. Actually, it's not we, it's mathematician, right? Anyway, so let's get right into derivative rules. In math, we tend to make the shortcut. So instead of adding, we mathematician develop multiplication table for us, right? So let's say if you 5 times 3, instead of adding 5, add 5, at 5 3 times, or 3 at 3 at 3 at 3 5 times, we just say 3 times 5 equals 15. The same like here. We want, instead of using tedious tasks, we try to use a shortcut to apply this, okay? So what is the first rule of our shortcut here to find derivative? The rule here we call number one, we call a power rule. Power rule, okay? And the power rule say, if your y function, y equal x to the power n, then when you take derivative of it, we call a y prime will be equal n times x to power n minus 1 on the top. Now keep in mind this notation of derivative, there are many of them. So this y you also can call an f of x, right? F of x equal x to power n. And this you also can write f prime of x, which is the derivative of this function, equal n x to n minus 1. Now, in the textbook, most of the textbook use this notation. So everything here stays the same, except this, they call a dy over dx. And of course, it's the same thing, rule, the same rule, right? Now, why they call it dy over dx? Because what they indicate is dy mean the derivative of the y function with respect to x, right? So that's why the notation come from. And most of the textbook use this notation. Now, because I try to make math as much as simple, so I like to use a similar notification, unless I have to use the complicated one. So at this moment, I'm going to just use the derivative is y prime or f prime x, right? Later on, when you learn the chain rule, so we will mention about this. That's why I introduce you on of the notation, okay? And basically, whether you call it f prime x or dy over dx or y prime is exactly the same thing, okay? Now, let's give example of the power rule. So the example of power rule, let's say you have a polynomial function, the basic one, very easy one, right? Let's say you have x to the power 4. This is the y function. So to find derivative, we find y prime. So y prime will be equal y prime will be equal, bring this down, it becomes 4x, and subtract 1 on the top, 4 minus 1, like this formula, we got 3. And that's done. That's how you use the power rule. Let's give another example. Let's say you have minus 3x to minus 5. Find derivative of this. It will be y prime equal, bring the minus 5 down here. So negative 5 times negative 3 will be positive 15. X, instead of minus 5, now become minus 6 because we subtract a negative, right? Minus 5 minus 1, it become minus 6. And that's it's our answer for now. Now, if you learn the past about negative exponent, you can bring it down and change it in positive exponent. And that's our final answer using the power rule. Very straightforward, right? So I just try to show you. Now, let's get into the second rule right away. If you understand the first rule already, let's go to the second rule. And the second rule here, let's say we call what do we call? And I'm going to frame this one so that remember now, this is the formula, right? Number 2, second rule is we call the sum and differences rule. The sum and differences. So what is the rule? If you have a function y equal f adding with the g, that's the whole thing, and you want to try to find the derivative is y prime, So what y prime will be equal? Y will be equal f prime adding with g prime. Okay, now let's write down another notation for this. Fx equal f of x adding with, and let's call this a different thing. Let's say h of x, g of x. So what is the derivative? Derivative is h prime of x, right? So what is h prime of x? H prime of x will be equal f prime of x adding with g prime of x. So basically, this rule just say that if you want to take derivative of a product of two functions, then you take derivative of each individual function and then add them together. Now it works the same for negative, subtract, right? It works. So I'm going to put underneath here the negative side as well. It means this can be a positive and a negative, adding or subtract. We use the same rule. So this is how it works. Now let's take a look at this example. Let's say you have a function y equal x to power 5 minus plus 2x to power minus 4 minus 3x to power 2. So how do we apply this sum and product rule? You can see this is a bunch of each individual adding, subtract together. So we just follow that. And so our y prime will be equal the derivative of each individual here using the power rule again, right? Back into here. So this example is a combination of power rule and the sum and differences rule, okay? So I'm going to bring down the 5 in front of the x, reduce this by one level on x to the power 4. Adding, but I'm going to time minus 4 to 2, so that become minus 8. X minus 4 minus 1 become minus 5. Subtract 2 times 3 is 6 x. So that is our answer for this operation. Okay, so that's how you can see that we use a rule of both power and some differences applied to here. Now let's go into the next rule. So the next rule is, let's go into it. We call the product rule. And what is the product rule? The product rule. Let's see how the product rule works. Let's say if you have an f of x function. I call this function is h again, equal a function of f of x, times with the function of g of x. So what is the derivative of it? H prime of x will be equal, keep this one the same, time with the derivative of this one, which is g prime of x, adding, so keep this one, time with derivative of this one, adding with now, keep this one the same, g of x, time with derivative of f of x. So alternate, right? First, we keep the first function, we time with derivative second function, adding with, now keep the second function the same as original, but multiply with the derivative of the first function. So that is the rule we call a power rule. Product rule. So let's say if you have an example, okay? Let's say if I have two functions, let's say 2x to the power 2 times with 3x to minus 4. So how do I do this function? Using the derivative. So the derivative of this function is y prime, right? Will be equal to keep the first function 2x squared, keep it the same, time with derivative of the second one, which is minus 12 x to minus 5, adding, keep this one the same, which is 3x to minus 4, time with derivative of this one, which is 4x. So now let's simplify a little bit this expression. 2 times minus 12 is minus 24. X2 minus time with x5 is x to minus 3. Adding 4 times 3 is 12. X to minus 4 is with x to minus positive 1, so it becomes x to minus 3. Now at this point, you have a like term. This is minus, this is add, x to minus 3, x to minus 3, which is, and subtract them, minus 12, right? And if minus 24 plus 12 is minus 12, x to the power 3. And you can bring it down, so y prime will be equal minus 12, minus 12 on the top, down here will be x, and this should be minus 3, so down here become positive. When you bring it down, it becomes positive. And that's your final answer. So you see how we can use this rule and get down to this expression, single expression, like that, right? Let me write this more clearly a little bit. So that will be equal minus 12 on top. Bring the x to the power 3, it becomes positive down here. And that's our final answer. So so far I have shown you how we use the rule of derivative to perform some of the function here. One is one power rule, second is the sum differences, the third is product rule. Now the next one will be the quotient rule. So let me go to this bar and I have to erase some of this. So I'm going to erase this. And sorry for taking the time to erase the bar. I really don't know how to, use the screenshot and just show you the screen. And I think that I'm more comfortable with show you on the bar because that's years and years I've been teaching in the school system, and I always use the bar and black bar, right, white bar. So now my purpose is just want to show you math, and whatever I feel comfortable and people feel comfortable, they can show you different way. I'm not so fancy about technology, so, but I will learn over the time, so please bear with me. So now I'm going to show you the last rule, which is we call a quotient rule. So what is a quotient rule? Let's say you have a function h of x equal f of x divided by g of x. So the quotient rule say you want to take the derivative of h prime of x will be equal, keep the denominator the same, time with the derivative of the numerator, minus, now exchange alternative, now keep the numerator the same, now take time with the derivative of g prime of x. All of this divide by g prime of x. All of this will square at the bottom. So that is a rule of quotient rule. Now let's find out how do we apply it. Let's say you have a y function, y equal x to the power 3 divided by 4 x divided by x minus 2 all of this to power 2. So let's say you have a function like that. How do we apply the quotient rule and find out y prime? So the question says find y prime, right? Derivative of y. So y prime will be equal, keep the first one the same, of the denominator the same, so x minus 2 to power 2, right? That's how the gx here conform. We keep this denominator the same. We multiply with derivative of the top, right? Numerator. So time with, use the power rule now, 3x squared, right? Subtract, keep the numerator, which is x to the power 3 the same. Time with derivative of this one, you bring the 2 in front of the bracket. And in here you have x minus 2 the same, and that become power 1, right? That's how we deal with it. And all of this will be over the denominator, which is x minus 2, all of them to power square. But don't forget, we have to square, right? Follow that formula. So I'm going to repeat this because it looks a little bit complicated. So I'm going to keep denominator the same, x minus 2 to the power 2, keep it the same. Time with derivative of x to the power 3, which is 3x squared, minus, now I'm going to keep the numerator the same, x to the power 3, multiply with derivative of this bottom, which is 2 times x minus 2 to the power 1. So I'm done. Now I'm going to simplify this, okay? So, now this is a little bit complicated if I simplify it. Sometimes in derivative, it's wiser to just leave it at this instead of simplify. But let's see how can we simplify it a little bit. Okay, so this will become two. You know what? I think it's a little bit complicated. So let's leave it the way it is. Just simplify this. Okay, so it's x minus 2 squared times with 3x squared minus x to the power 3 times with 2x minus 4. Right? And just distribute this. So simplify the bracket a little bit. All of this over x minus 2 to the power 4. At this point, if you want to simplify further, we still can do it using our algebra skill at the beginning. But if we just leave it this, the answer, that's okay too, because this is our purpose of apply the quotient rule to find the derivative of it. Now let's assume that I want to simplify it, okay, this expression to see. That would be x squared minus 2x minus 4x plus 4. And time with 3x squared minus, this will be 2x to power 4 minus time this minus time this become plus 4x to power 3. All of this x minus 2 squared. So this will become, if we simplify further, it will become 3 times x squared will be 3x to power 4 minus 3 times 4 is 12x to power 3 plus 12x to power 2 minus 2x to power 4 plus 4x to power 3, all of this over x minus 2 squared. So it's not a good idea to simplify a derivative of the complicated function, but I just show you and it doesn't matter, right? So our y prime will be equal 3x to power 4 minus 2x to power 4, all this is minus, it becomes 1x to power 4. So we have x4 minus 12x to power 3 plus 4x, so it becomes minus 8x to power 3. So that gone, that cancel with this, adding with 12x squared, all of this over x minus 2 squared. So this look a little bit, you know, more neat. So that is our answer using the quotient rule. So today I have introduced to you on the derivative rule. I think that the last one is a chain rule. Maybe I should leave that for the next video. And in the future, you will have, you will see how some of derivative powerful more when we use the same rule but get into derivative trigonometry, logarithmic, and so on. So I hope you enjoy my video teaching, and bye for now, and see you in the next video for more about derivative. Bye for now.